So hello guys, this is my first tutorial. So I'm not good at making tutorials. This is my first video making tutorial. So okay, I have this main camera, the background, the character. There is a box collider attached to it, and there is a platform. Just a platform with a sprite. This is a sprite. Now what we want to do that in Angry Birds, when we drag the red in any direction, it will just predict a path. I've just in the red I have a rigid body called rigid body. The gravity, just stay here. See that I have done the gravity 0, so if I play, there is a rigid body, there is a box collider attached with it, but it won't fall, okay? It won't fall, so I have done the gravity equals to 0, it has a mass, it is a rigid body, but it won't be affected by the gravity, okay? And I have freeze rotation in the z-axis, it doesn't matter, just for the simplicity of the case. And I just start writing the script, okay? I'm just starting the script of this dragging, and so I'm just starting with adding a new script on this red layer, which I have attached a box collider and a rigid body with it, which gravity scale is 0, okay? So you know why I have done that, right? So I'm just adding a new script, player script, create and add. So I've read the script, it is opening, okay? So what do I want? Firstly, to drag this red. I want to drag this red wherever I want, right? Like I want to, if I do this, okay? So I want to do this type of activity I want to do, right? I want to do this type of, I want to make sure that the red moves wherever I drag that red, okay? You know what I'm trying to say, right? So firstly, I will take two vector 3, like I will take two vectors, the first denoting the start position and the other denoting up to what point I want to drag, and I will leave the drag option, okay? Like I will start dragging by clicking on the mouse, and on which point I will leave the mouse button, okay? So these are two positions represented by vector 3, okay? So I will declare two private vector 3 denoted by start pose and another denoted by end pose, end position and start position. I don't want anything in the start method, but in the update method I want on every, if the mouse button is clicked, the left mouse button, the left mouse button is clicked if input dot get mouse button, okay, 0. You know that 0 is the left mouse button, right? So now there are three methods, okay? Get mouse button up, get mouse button, and get mouse button down. So we will start if the get mouse button down, if the left mouse button is pressed. So I want to start calculating my start position, then calculate up to how much I drag the left mouse button. So I will use the input.getMouse button function, and when I leave the left mouse button, that means the input.getMouse up button will be used for calculating the start position and end position. I will just tell you what I'm telling. Okay, so first I will create a function update. In the update function I will write if the button is just clicked, the left mouse button is clicked. So I will just create a start. I will initiate the start position with the game object dot transform the position. It is correct because I want the starting position of the game object, right? And for the end position, I want that up to how much distance the game object is dragged, okay? So for dragging, I know that input dot get mouse button is used, okay? Get mouse button is 0, not down, but just the get mouse button 0. From dragging, what I want when it should be doing the drag, okay? So it should follow the mouse, okay? I want that it should follow the mouse when I'm dragging the game object, right? Like this. So now what I need for that is that end position and position and pose is, we will initiate this as a value. So what we want with the end position is that camera.main, I will take the camera.main function and its camera.main.screen to world point input dot mouse position. Sorry, mouse position. Yeah. What does camera.main screen dot input dot mouse? It tells us this whole thing tells us that where is our mouse at the moment. Say we want this end position to be reflected in the game object. So we want the game object dot transform dot position. We want it to be end position. Okay. So I'm telling. So this is now. I will show you what does this mean. Okay. So when I play this, just focus on the red's vector position. Okay. It is minus 1.65, minus 1.8. Okay. So when I have not clicked. When I click this, it disappears. It actually doesn't disappear. It is just still here. It is coming on. It is here. When I have dragged, I have not left the left click button. It is just here, but we can't see because see the z is minus 10. So we want this z to be 0 as it was in the initial time. Because the z is minus 10, it is not appearing into the camera. So what we want to be 0, so we have to add a new vector 3 to compensate the minus 10 on the z-axis. So what we want is 0, 0 on the x and y. Sorry. Oh my god. And minus 10 on the z-axis. Okay. So now you will see that it is going to where we want it to go. Okay. So just let me tell you what I'm trying to say. Oh, okay. It is. Oh my god. You have to add a 10, not subtract. And okay, when I play this, see, this is what I'm trying to say, right? It is right now, correct? Yeah, okay. clicking, dragging and leaving. But on leaving, what we want that it should actually, when we drag, it should predict a path, okay, where I want to go, okay. Like I'm doing this, and this should have a projectile path for each of the following where it will go, right? For this it may have this, for this it may have this, okay. So this I want to do. And on dragging, I want the predictable paths, all the possible predictable paths, okay. So firstly, I will do that later, and first I have to make a force that will have leave, and on leaving this, it should just, I have leave this, and it should go on this path, okay. So for this, I will write a force, new force, okay. So on leaving, okay, just let me make a function. If input dot get mouse button up, on upping, up means the leaving the left mouse button, okay. So when I leave this, what I want to do is that we have to calculate the force, okay. It should depend on the end force and start force. It is true, it is correct, right? Just let me make a function. If input dot get mouse button up, on upping, up means the leaving the left mouse button, okay. So when I leave this, what I want to do is that we have to calculate the force, okay. It should depend on the end force and start force. It is true, it is correct, right? So what we want is declare a new private force, and we should have a force factor also, that how much we want that force to be affected on the player, right? So we will make that public and make the force factor private, okay. Force factor public and make the actual force at player to be private, okay. So public, okay, it should be vector 3, because it should be, it is the difference of end position and start position multiplied by something, okay. So public vector, private vector 3, let's say force at player, and just make on leaving, okay. On leaving also, what we want that on leaving, I have said that make this gravity scale equals to 0, because it doesn't fall, okay. Because it doesn't fall on the initial and final state when it is not having any interaction with the player, right? After interaction having player, and after having a force, I want that it should go on the path, but when I apply only force and its gravity is 0, so it will go on this path, okay. I want to be on the projectile path, so I have to initiate the gravity to be 1, okay. So in the I have to make the, when I leave the mouse, I want that this rigid body's gravity scale should be 1, okay. It above this, and I will just make it private, no need for it to be public. Private rigid body 2D RB, okay. Just make rigid body, okay. Just make it rigid body. So I want its rigid body's gravity component, rigid body dot gravity scale equals to 1, okay. So what will it say that you will just see what I'm trying to say. When I leave it, its gravity affects the player. Just see what I'm trying to do. See, and the gravity starts to affect, okay. Something is not cool. Okay, I'm so sorry. I have to initialize the rigid body component. Rigid body equals to get component, rigid body 2D. I'm so sorry, guys. Now that will affect. Okay, just let me restart this. Okay, now what will happen that this is what I want, right? To affect the rigid body with the gravity when I leave the mouse button by dragging, after the dragging, okay. And after the dragging, I want the force of end position and start position's difference affected. The difference is factor to be affected on the rigid body, right? The force at player will be the actual difference between the bodies, and of which amount I want to affect that player with will be the public float, private float. I'm sorry, I have to make it public. Public float. Let's make it public float. Force at player. Force at player is their force factor. Making variables is a very difficult thing. Else everything is very easy, but making not easy. Making the variables in all is very difficult. Naming the variables. Okay, I'm doing it. Also, what I want that making on leaving the mouse button, I want the end position minus start position to be affected. So firstly, we will calculate force at factor. Force at player, sorry, not factor. So what I want that force at player, I want to make it equals to end force minus start force. Start force. Actually, what I want that this force at player will be not actually force at player, but this force at player we will need it when calculating the path predictor. Okay. So I need it here because I need every force at player to be changed to be affected on the path predictor. Okay. So every force factor change, the path predictor will also change because the end position and start position will affect the path predictor. Okay. So I want the force at player to be calculated on the dragging part only, and we will use it here on the velocity part. Okay. So the rigid body dot velocity will be affected by that force factor calculated on the drag part. So let's make a comment on what are we doing where. So here we are clicking, dragging, drag, and leaving. Okay, so we will understand at what part we are doing what. Okay, so in the dragging part we want force at player more than we need it in the leaving part, because in the dragging we need the path predictor to be affected at every end position changed. Okay, we're trying to understand what I'm trying to say. Okay, and in the rigid body dot velocity we need this force at player to be used in a new vector 2. Okay, because velocity needs a vector 2 component return. So new vector 2 we need force at players dot x or minus force at player dot x, because actually the start position minus end position will have, we do not want the force to be in the direction of the end position, right? We need end position to be negative because we want to move on the opposite direction where we drag the player. So minus force at player x component, and we multiply it by the force factor. Okay, we can write it like this also, just this, but we want this to be multiplied by the force factor, because we don't know that how much it will affect the rigid body. Just the force player dot x. Okay, so we multiply by force factor, comma, minus of force factor dot force at player dot y multiplied by the force factor. Okay, so that force factor is done. So this is the velocity. Okay, so let me just save it and run on the computer, and let's see. Okay, there is a compiler error. I don't know. Oh, this is just what I want. This is just what I want. The errors of the brackets. I wrote multiply. Okay, I don't know what happened. I typed multiplication. Let's see. Okay, I have clicked, drag, leave. Okay, not happening. I don't know why. Okay, force factor. I have to just make it something. Let's make force factor. Force factor to be 5, 10, 15, 10. Let's make 10. Let's see what happens. Yep, cool, right? Cool. We will make a space bar. We need a space bar because I don't want to do every time a play button. Okay, I have to just restart the play button and all this. I will make a new space. When I hit the space, I want that it to be respawned. Okay, when I hit the space, I want to be respawned. So for that, if input, which is right, if input get key code dot space. Now I want that first of all the gravity should be 0. Okay, just make sure you do the gravity is 0. Rigid body dot gravity scale equals to 0. What I want next to be rigid bodies, velocity to be 0 equals to vector 2.0. Just do not make it 0 like the gravity scale, because it returns a vector 2. It needs a vector 2, not returns a vector 2. It needs a vector 2. And what I want next is the player's position to be the initial position where it was. So let's make a new init position, private. Let's make it public so we can just copy paste from the transform of the player. Okay, public vector 3 init initial position. Okay, and we want this initial position to be 0. I think so. No, initial position I would not want to be 0. Initial position I will copy it from the transform of the player. Okay, so I will do that there. But I want that rigid body to be on the. I want that game object transform the position to be equal to the init position. Okay, so let's see on the unity. I want this init position to be equal to the initial position. Okay, so when I hit play, I will see that on space I am able to come on the initial position. Right, it's nice. It looks nice, right? It looks nice. Now just what I want is a path predictor. Just a path predictor. So for that I need some dots. Okay, so just make a new. I need to make a new prefab. I think so, not a sprite, but it's prefab of a. I need a prefab of a sprite. Let's name it trajectory dot. Actually, we will make the array of this prefab. You know what I mean? You know what I'm trying to say that. Okay, just I want a simple dot, man. There is a dot. Okay, sorry. Okay, just let me this dot seems cool. Else is 0. The transform should be 0, and make it prefab. Dragging in the assets folder. Just delete it. We don't want it to be appearing anyway. We just want when we drag and in the path predictor. Okay, so let's do that. First of all, what we want is public. We need that dot or the array of dots to be instantiated on dragging part. Okay, so public game object trajectory dot. We will drag the trajectory dot prefab in this public component. Public trajectory dot. Okay, and in here we will make a private game object array in which we will store these dots. We will store these dots. Okay, so trajectory dots, and let's make it a number. So when we have to instantiate the game object. So when we need to instantiate the game objects array, so we need to define about how much we want to make that array to be. Like what I'm trying to say is like this: trajectory dots array should be a new game object array of size something like 10 or 20. So we don't want it to be static. Okay, we want that we decide outside the script. We don't want it to be hard coded. So we will make a new number, public int number, to be what defines in here. Okay, so replace it by number. Like the hard code makes it difficult to every time change the script, come to the script and make it 10, 20, 30, whatever. We don't want that. Okay, like the Jon Snow, we don't want it. Just kidding. So let's start what we want. So we just want to, okay, just let me save it, go to the Unity, and we will see here game object, drag this prefab from the trajectory dot to this trajectory dot and make the number to be 10 for initializing. Just make it 10. We want 10 dots to appear when we drag, 10 dots to appear. Okay, so we need on the clicking, we need to instantiate on the, let's say, game object's position. We need to instantiate on the game object's position, right? Where the game object is, just make them there, right? So we need this, all the dots we need to be instantiated first on the clicking. So what we want now is we want to instantiate all these dots at the position of the rigid body or the position of the red player. Okay. So what we will loop all the dots. We have to instantiate all the dots. We have made this trajectory dots instantiated. We have not instantiated on the. We have instantiated on the script, but we have to instantiate on the Unity. For instantiating, we need the for loop, and for each. Okay, so for I, the length should be the number, and all else is what we need to be. And all we have to, and we need all the dots. All the dots to be instantiated. Okay, what we want to be instantiated. Okay, so we want trajectory dot prefab to be instantiated. Okay, we're trying to understand what I'm trying to say, right? We want the trajectory dot prefab, which is this, to be instantiated where? To instantiate it on the game object dot position. Okay, game object dot transform dot position. Game object transform. We need a transform only, not a position. Okay, so on every dot we want to instantiate on the game object's position. The transform, we have to pass a transform component to this argument, but not what I'm trying to say is at every dot, like these dots, we have to instantiate on the these dots, 10 dots, like the number is 10, we have defined it 10 outside this. So at 10 dots, we need to instantiate every dot. I'm iterating through this loop, every dot should be on the game object's transform. Okay, and now when we drag, we want this dots to be at the position where the path would be. So we have to make a calculate position function in which we will calculate the position in the drag path on the basis of this end position and start position, right? Actually, this four separate the difference between them. And at each end position, start position is same for all the dots, okay? But the end position will be different. So we want this calculate position. We will make a new function. Let's make a new function called private. I will make it private. But it will return a vector 2. It will return a vector 2, meaning it will return a distance. It will return the distances of each and every dot. For each and every dot in the dot game object array, trajectory dots array, we will have, for each and every dot, we will have the particular dot's calculated position or predicted position. So calculate position, and we need in this argument to be the time. How can we differentiate these dots on the time? We want 10 dots on 10 different timestamps on 10 different times. On the 0.1 second, we want the first dot to be there. On the 0.2 second, we want the second dot. So we'll make a float time. Okay, or let me say it elapsed time. So we know elapsed time. So we can differentiate the dots on basis of this time. We want to return. So what we let's assume that this is a player and this is the initial position. This is the initial position. This is what it is when we drag the mouse and leave it. This is the final position. So what we want is this is the calculated position as we have looked at, and this is okay. So this is the predicted position. Let's say this is the predicted path. Okay, let's say this is the predicted. So this path, we can predict this path by simple gravity. So let's say that we have an object, we have a player, and we have its initial velocity in this direction, u, and we have this x0 as its initial position, and we at a time t, we want its position to be somewhat xt at a time t. So how can we? So we can find this time t by applying Newton's laws of motion and Newton's laws of equation. I think it's Newton's laws of equation that xt equals to x0 plus u times the initial velocity times the time, this time t of the position we want to evaluate, plus half at square. Okay. So here we don't have acceleration as a because we don't have acceleration of our body, but as acceleration we have gravity acting every time. Okay. So we replace this g, we replace this half at square by half g. So this g is a gravity. So we replace this a, we don't have acceleration here, so we replace this a by gravity, physics 2D dot gravity, which we will evaluate from the physics 2D library. So it's okay, so it's cool. So alright, we will evaluate the position of every dot differentiated with a time at 0.1 second, at 0.2 second. So here it will be 0.1, 0.2, this t will be 0.1, at 0.2 second the distance will be what, at 0.2 second the distance will be what. So the difference of each dot will be its time, and the position will be calculated by this function. Okay, so we want x0, u, t, half at square. T is the elapsed time, by the way. Okay, so let's make it. So what we want is the end position, the initial velocity, and that's it. x0 plus ut plus half at square. So we want to return a new vector 2, and in the vector 2 we want the end positions and positions dot x comma end position dot y. Okay, why I'm doing this, right? End position is the position which we leave the drag part. Okay, So we need the end position. From that point we want to calculate the distance. Okay, so we need the end positions. What we want next is to return the ut part. Okay, so this is this is the x0 part. Next we want the ut part. So u means the initial velocity, which is this, which is the velocity. Okay, so we know that we have to return this. We have to add this. Okay, Control C, Control V, and this will be the ut part. For the t we have to multiply it by the elapsed time. Okay, because we have to differentiate all the dots. So it will be differentiated. These dots will be differentiated by this elapsed time. For every new elapsed time, we will have a new dot instantiated at that position. We have instantiated these dots at the game object's transform, but we want a dragging each and every dot's position to be changed accordingly. And how will we differentiate the 10 dots? We will differentiate on the basis of the time on which time the dots will be where. Okay, so we want this ut, and next we want half at square. So it will be just a 0.5 f star multiplied by the physics 2d dot gravity multiplied by the elapsed time square. So we'll just multiply it by two times. So I think it's fair now. The calculate position function will be fair. So now we want this calculate position function to be called every 10 times or every number times this is end position is changed. So what we want is that in the for I will iterate this number times, and what we want that the trajectory dots prefabs I dot its position. Basically I want its transform that position to be the position that is written by the calculate position function on the time that is defined by I. At every 1 second's difference, the position of the player will be very far away. So we won't be seeing the 10 dots for 10 seconds. Basically what a jump or what a path exists for what a path's lifetime is for maybe 1 second at max. So we do not want to be 1, we want it to be multiplied by the 0.1. So basically what 0.1 f will denote, what I mean to do by this is not at every 1 second difference, but at every 0.1 second difference, all the dots will be there. Okay. So let's go in the Unity and see whether it works or not, even if it works or not after this much amount of time given to it. So ready, I'm clicking, just wish me luck, clicking and dragging, no, not appearing. Okay, I know why. See, you know that these are instantiating. Okay, you can see it here. These are instantiating, right? You can see this. These dots are instantiating, but its size are very low. I'm thinking about it. So this trajectory dots are the scale 1, 1, 1. And here we can see that it is reduced by scale of 0.025, 0.05 in the parent. Okay, so it is in the case of my scene, but in your scene it may not be the case. So for my case only, let's increase the size. And now I want to see the path. Okay. Yep. Thank you very much. Is it going where I want? Okay. We want to destroy. We will destroy. Okay, I want to just make the space. Okay. Let's keep space. All the paths are shown. We want to destroy these paths. Okay. We want to destroy these paths on the leaving part. Okay. So let's just leave and we will make the jump. We will make the path. I see the path to be a little bit imperfect. On the leave part, we want that a for loop must destroy the number and destroy trajectory dots prefab. I think trajectory dots I. Destroy the trajectory dots I. So I think it will fix it. Yep, it's happening. Space. Yep, it's happening. It's cool, right? So what we do? So let's just decide to make the force factor to be 8 and let's play. So basically I should have 15 dots with force factor 8. Let's make the 4 dots to be less. The dots are way more. Let's say dots should also be 8. It's cool. We should see 8 dots with the force factor is 8. So yeah, it looks cool, very cool, right? The initial dot is also moving with the player. It's very cool. It looks cool. So it's nice. The path predictor is cool, right? The best path predictor. I know the tutorial is a bit messy. I know it's a bit messy, but it's my first tutorial, guys. So bear with me. I don't like tutorials like this, but I'm making it anyway. So bear with me.